How can Dassault Systèmes 3D experience platform support companies in transforming their operations to be more productive, more sustainable, and more competitive? I'm pleased to welcome you to this presentation, which is part of our overall Virtual Hannover Messe 2021 presence. We want to take you on a journey and highlight how our offering can generate tangible value by providing a collaborative environment that empowers businesses and people to innovate in an entirely new way. Do your customers approach you with increasingly specific requirements? Can you fulfill these individual demands with minimum lead time and maximum quality? Are you sure that you even earn money at all when you take such order? These questions are of ever higher importance to our clients, and we are proud to help and be pivotal in addressing them. In the next 30 minutes, we will follow various roles within a company and see how they use Dassault Systèmes solution from an interactive management meeting in which a new customer request is discussed, all the way to the production of the new variant on the shop floor. But now, let's join the ongoing management meeting and see how to deal with an innovative new customer requirement.
At the start of our scenario, the company holds their weekly Agile management stand-up meeting. The objective of the meeting is to align between all participating departments, which are sales, supply chain, manufacturing, engineering, and production. They start by defining the agenda for the meeting. To stay in time, they also set an objective for the meeting's duration. In this meeting, 2 participants are joining remotely and contribute to the meeting by collaborating online through the platform. As first part of the meeting, the retrospective view, the conclusions and actions derived from the previous meeting are reviewed and discussed based on an action log. For this purpose, the owners of the tasks update the status of their actions and present the relevant outcomes of their completed activities. Following that, they take a look at the performance of the organization. Based on the KPIs and the trends apparent from the charts, the team can immediately discuss and decide on actions they need to take. Once the review is completed, the next item on the team's agenda is to update the plans and forecast for the coming quarters. During the discussion, the field sales manager informs the team that a customer has requested if a new variant of an existing product can be supplied. As a first step, the team discusses the business potential and concludes that a more thorough analysis is required, for which they create an action. The actions defined here are automatically consolidated in the action log, which helps the team to keep an overview of all tasks and responsibilities. As a next step to reply to the initiatives from sales, the team decides to have a closer look at the 3D model of the product to see which modifications are required. Also here, they conclude that the customer request appears an interesting opportunity. The implications for the production process and plant utilizations, however, need to be clarified first. For this purpose, they create tasks to ensure manufacturability of the new variant and assign the tasks to the respective manager. To conclude the meeting, the team looks at the identified actions and discusses about the timeline so that a response can be provided to the customer and the production can be ramped up.
So you have just seen a management meeting in which sales brought forward a new request to supply a new customer-specific variant. We will now see the first step triggered by the customer request, which is sales and operations planning. This is an activity performed in my department, the technical planning department. The goal of this activity is twofold. Firstly, we want to verify that the new opportunity is economically viable. Secondly, and in addition to that, we have to ensure that sufficient capacities are available in the supplier network. In the following part of the workflow, we show you how our solution can support you to achieve this objective.
As start of the sales and operations planning, the demand planner captures relevant information in the collaborative forecasting process. All characteristics of the opportunity known at this point are identified for further tracking to enable a statement about the final revenue and profit contributions by the opportunity. The demand planner therefore configures the parameters, such as the probability of successfully converting the opportunity, planned due dates, and amounts for delivery over multiple periods. The solution allows to project the demand on multiple independent criteria such as product, sales channel, technology segment, region, and others at any combination of different levels within the hierarchies. This makes the opportunity transparent for sales, demand planners, and other planning team members. Next to this, the process provides deep insight into the impact of the new opportunities on multiple time series and in different dimensions, such as the revenue contribution on product family. Performance indicators such as volume and revenue are reflected both in the individual time series and on the level of global KPIs. This ultimately allows to judge which business potential the new opportunity offers. We just saw how the opportunity became part of the unconstrained demand plan. In the next step of the planning process, the supply planning team will try to make sure that the opportunity can be fulfilled in combination with the demand of other products. For this purpose, the supply planner takes responsibility for allocating volumes across the entire value network. The solution automatically creates the supply plans by applying optimization strategies, harmonizing potentially conflicting planning KPIs while adhering to business-relevant constraints, such as capacities or limited quantities of supply. Our new opportunity is considered with the appropriate priority, respecting finite capacities and limited supply quantities across multiple operations and sites. The supply plan reflects the allocated demand and supplies across the entire network to fulfill the new order. This provides full visibility on planned production, inventory positions, and transports from the initial delivery of parts and components until the final assembly. To maintain the global optimum, the plan is steered and expressed by global KPIs. Here we see how multiple scenarios can be created and compared to support make or buy decisions. The performance of each choice is represented by its individual effect on the KPIs. Comparing scenarios also supports in making informed decisions based on facts and figures. You can explore the trade-offs between KPIs such as fulfillment rate, revenue, and cost to identify the most suitable business decisions. Hence, the solution puts the supply planner into the position to choose the best allocation of the new opportunity in the company's supply network. Accordingly, the sales rep can get back to the customer with a matching offer. As soon as the customer accepts this offer, the opportunity is no longer an opportunity, it is now an actual customer order. Now that the first due dates for production and delivery are approaching, the factory planner has to make sure that the entire supply network runs in sync to fulfill the order on time, from suppliers to component plants to the final assembly. The planner keeps track of dependencies between operations and materials, considering production timings, transport lead times, and supply confirmations, from incoming parts to in-house production of components to the final assembly. The system automatically replans dependent steps in case changes occur, respecting finite capacities, and flagging alerts in case of conflicts, so that the planner can initiate measures on time. Luckily, all steps for the new crane variant are on track. Also, the overall situation in the particular week of production seems well balanced and gives the confidence that the ordered products will arrive at the customer as promised.
You have just seen the first step of our scenario. Using the S&OP solution, we could verify that, from a business perspective, the new variant requested by the customer can be produced with positive net worth. Moreover, we verified that the required capacities across the entire supply network are available and developed a schedule that orchestrates all tiers of the supply chain to fulfill the order. We could hence confirm the customer request for a new variant and make an offer, turning the opportunity into an actionable customer order. Now, before starting with the production of this new variant, we have to verify that the process plans for the operators are still okay or if something needs to be adapted.
Therefore, we will now take a look into the manufacturing engineering department and see how the process planner deals with the new product variant. Once the changes in the product design have been modeled in CAD solutions like CATIA or SolidWorks, the Delmia portfolio allows you to virtually plan, simulate and validate your production processes and manufacturing assets before you actually start with your production. You can define product processes and resource structures and combine them in a generic way. In the following part, we show you the workflow and how to create and manage product and process variants together with the resource based on a digital thread and in a holistic view.
For the given scenario, we start in the role of a product manager to look into the product structure and to define the new product configuration as requested by sales. The new product configuration is based on an existing product but has a couple of changed components. Here we see how the new configuration is generated from the existing product. In the background and not visible to the user, automated checks are applied to ensure that the new variant is valid. With this new product configuration, let us now take a look at the Manufacturing Bill of Materials, or MBOB. You can derive the MBOB directly from the CAD model of the excavator and display it as a 3D graph of the assembly sequence. We now use the newly created configuration to reduce the manufacturing bill of materials of all configurations to the actual components of the new configuration. In this way, an initial visual verification of the processes and components can be accomplished quite easily. In addition to the materials used, the engineering department can transfer further technical information along with the CAD model to be displayed in the manufacturing bill of materials. In this example, we see that two different assembly technologies should be used: point welding and seam welding. Together with the assembly sequence of the product captured in the manufacturing bill of materials, we move on to process planning. Similar to the manufacturing bill of materials, you can also filter the process plan shown here to only display processes used by specific configurations, as we did here for the new product variant. Now, we have to define the assembly sequence and add more details to the process steps, such as the time required for assembly. Once we have provided the detailed process duration for each step, we can carry out workload balancing and visualize the result in this Gantt chart. With the manufacturing bill of materials and the detailed process plan, we can proceed to the next step, which is generating 3D work instructions. Here, we navigate through the process and select one of the steps to generate the work instructions for this operation. After selecting the step, the 3D view automatically builds up the right scene based on the information from the product flow and the manufacturing bill of materials. Here, we see different views of the 3D model proposed by the system. We can now add further information to these views, such as material requirements specified by the engineering department. This information will be used later on to guide the operators when executing the production process. But back to our current process planning, where we now take a deeper look into the welding processes. Here, we link the process steps to specific resources, all based on one consistent dataset and without needing multiple dedicated systems. Here, we add the technology information to the process step, describing the required seam weld. This information will be relevant for our robotics specialist. Now we compute the process model of the product with all the technical information, such as the welding seams we just defined, but also the position and orientation of the part to be produced. Now, let's jump into the role of a robotics specialist. The robotic welding cell you can see here was also designed in this application. You can create a robot program that we can simulate and validate in the welding cell, which you can then download and send directly to the real robot controller. Our solution hence enables you to perform virtual commissioning and signal handling, supporting you in efficiently preparing your automated assets.
This concludes the steps of the end-to-end manufacturing operations engineering. You could see how the entire process engineering workflow can be performed on one single platform with one single user interface and based on one single dataset, which makes this collaborative process not only fast but also very efficient. At the same time, we keep full traceability of the information from the technical parameters of the original product design until the very end with the robot program for producing the new product configuration. Now, with the modified process plans, work instructions and robot program, we are ready to ramp up production in the plants.
Now, as last step, before we are able to produce the new variant, we need to include the order in the production schedule for the shop floor. Similar to the planning on supply chain level you have seen before, the goal here is to come up with a feasible schedule which is taken into account capacity constraints with regard to machines, tools, and employees, as well as our KPI objectives. And the planning should not only consider the actual production process, but also the logistics, quality-related tasks, and eventually also maintenance activities. So in the following part of the workflow, we will give you an idea of how our solution supports you in achieving this.
This is the view the production planner sees when opening our solution for the planning and scheduling on plant level. It displays the plan for executing the production orders across the resources and machines in the plant. Each resource is displayed as individual row, and each block in the rows represents a production operation for an order. The network of production operations of a specific order can be revealed easily for intuitive understanding of the dependencies. The right top corner of the screen displays important key performance indicators to support the planner with immediate feedback about the quality of the plan. As you can see, the current schedule yields a service rate of 94%. If the planner wants to check the planned utilization rate of an individual resource, our planning and scheduling solution offers the capability to display this in a detailed view. Alternatively, the planner can check the utilization rates in the resource overview. The yellow marker on this operation informs the planner about a new schedule element, our new product variant. Before modifying the production plan, the planner saves the current simulation scenario. This enables to compare the previous planning against the modified plan. The planner wants to avoid unforeseen challenges with this new variant and decides to execute this operation earlier by dragging and dropping the operation in the plan. The solution provides a visual support to which resources this operation can be assigned. As displayed in the top right, executing this operation earlier will decrease the service rate to 91%. To determine the optimal production plan with this early start date, the planner pins the operation to the position in the schedule and starts the optimization. As a result of the optimization, the service rate of the plan is now at 93%. Since the service rate is not the only relevant KPI, the planner saves the current simulation scenario to compare it to previous simulation runs based on multiple KPIs. This is accomplished by opening the performance comparison that displays all saved simulations and their respective KPIs. Next to the overview of simulation runs and KPIs, also individual indicators can be intuitively compared in the charts below. In the table view, the color of the KPIs helps to determine the most suitable schedule. With the capability of the Delmia planning and scheduling solution, the planner can perform multiple what-if assessments and find the best overall opportunity for producing the new variant.
We have just seen how easy the complex task of scheduling can become when you have the right tools. It only required a few clicks for the planner to include the new variant into the production schedule. You could easily see how the solution helps to make sure that the new variant can be shipped to the customer on time, but also to keep the effort for planning to a minimum. As all production steps and resources are now planned, we can proceed with the execution of the order on the shop floor. We also provide solutions for process execution that help you perform your shop floor operations in an effective and efficient manner. In the manufacturing execution domain, our goal is to ensure that all operations, be it in production, maintenance, logistics, or quality, can be integrated and executed seamlessly. For this reason, our solution can be opened on any type of device, from handheld to desktop PC. The following part of the workflow will give you an impression of how our solutions can support the operators in producing new variants.
As a first step of producing the new product variant, the operator logs into the solution. What is shown first is a list of tasks that is ready for execution. The operator selects the first operation, which belongs to the new variant, and directly proceeds to the work instructions that illustrate the first production step. Next, the operator enters the serial number of the parts involved in the operation. The traceability and genealogy features help to ensure that only the right components are used in the respective operations. Also, the system directs the operator to execute quality measurements as they were defined in the process planning step. This information will serve as basis for ensuring traceability of all products and processes. As we see in the screen, the system also provides the applicable specification limits for the quality characteristics that allow the operator to directly interpret the measurement results. To confirm that the quality meets the specifications, the operator receives an overview of the recorded values. For more detailed information on the performance track record, the operator can view the history of recorded values also in the form of a configurable chart for statistical process control, or SPC. This enables all team members to take corrective actions when needed. Once the operator is finished, the operation is reported complete along with a qualitative result, which is good in the shown case. Before starting the next production step, the operator checks the required components. As indicated by the font color of the component list items, it becomes directly apparent that the first component required for the assembly is not available. To obtain the missing component, the operator issues a replenishment request, which is sent directly to the warehouse for picking. Now we jump into the role of a warehouse operator, who is supported by the solution on a mobile device. The scanner shows the picking order that was created by the replenishment request. The warehouse operator starts the execution of the picking order and is directed to the right warehouse location to pick the needed components. The operator confirms the container in which the part is stored. After this, the system shows the target location where the part is needed. And after delivering the missing part to the location, the warehouse operator confirms that the replenishment has been completed. As we can see in the parts list, the operator now has all the components needed for assembly and can start the operation. Also in this step, the operator receives support for producing the new variants in the form of work instructions that were created in the process engineering solution shown previously. In each step of the assembly process, the solution supports the operator by providing intuitive visualization. Also in this operation, the operator collects all genealogy and traceability related information and assigns it to the production order and unique ID of the manufactured product. This delivers a solid database for achieving high-quality products and continuous improvement. Nevertheless, even in case of unplanned quality deviations, the operations management solution supports the operator to report quality issues. Among others, quality issues can be communicated visually based on a 3D model of the product. Quality issues captured in this way and other information can be easily fed back both to the product and production engineering departments. In this case, we can see that the operator provides additional information on the detected issue. The operator provides information on the category of the detected issue, which enriches the information base for future quality improvements. Eventually, the worker reports the operation to be complete. This will trigger an update of the order status in the ERP system. The production of the new variant is now finished and the product can be delivered to the customer. As the last shop floor activity, the operator creates an electronic manufacturing report and attaches it to the product. This configurable report contains all parameters captured throughout the production process and therefore can be used to prove the quality of the final product.
So this was the last process step of introducing a new product variant, which is now ready and can be delivered to the customer. We have seen how our solutions enable you to involve different functions in production into a streamlined process, covering the actual production process, but also quality and logistics. In fact, this was just a small fraction of the opportunities our solution provides you in this domain. We also saw the connection to the previous steps, like production engineering. We saw the work instructions, which shows how information and documents from the process planning activity can be integrated in the execution. But we also saw how information captured during production execution can be fed back to the engineering departments in a way that is very easy to understand.
This is the right time to leave our scenario. I am very certain that in the next management meeting, the corresponding activities can be reported as successfully completed. And once again, the proven customer focus will leave an impact in the marketplace. So, what did we see? We witnessed how the Dassault Systèmes solution has been used to evaluate, plan, and execute the production of a new customer-specific product variant. This is fully in line with what we get reflected as the major benefit of our 3D Experience platform. Centrally capturing and sharing knowledge and know-how, which you typically find distributed in the organization, fostering collaboration between various roles within an enterprise, and thus being the enabler for innovative new processes and operational agility. In addition, I want to highlight 3 key takeaways. First, supporting close collaboration on the same up-to-date data and information makes all the difference when you need to take fast and reliable decisions. Second, Dassault Systèmes is uniquely positioned to provide you a full software portfolio to drive your global operations. From evaluating the impact of a new customer requirement in your value network with operations optimization, to reassessing the impact on existing process plans and the necessary changes to the programs of resources or factory layouts in operations engineering, to optimized dispatching of the actual customer order, tightly integrated with your ERP system, and guidance of your workforce executing with operations management, we can provide it to you. not only with the recognized solutions in their respective domain, but especially in building and supporting end-to-end processes combining the virtual and the real world of operations. And third, it is never the software solution alone that creates value. You have a unique set of business priorities that comprise the expertise of your workforce, the IP in your processes, and your technology roadmap. When partnering with you for a digital transformation journey, we employ a methodology, we call it value engagement, that takes these priorities into account to jointly define a plan of the solution implementation with the highest business value for you. We have many clients that closely work with us and for whom we defined and built their solution together. Here you see a few from various industries and each with a very specific goal and focus. We invite you to follow the provided link to learn about selected success stories in more detail and understand their respective challenges, the solution we jointly built, and the achieved results. Thank you.